Hello guys, welcome to session adolescence. So we are still on vector 2, right? We are still on vector 2, but moving on other concept, right? So we're given the point A, the coordinates 3 minus 6, 1. And the line AO is the equation R is equals 7, 1 minus 5 plus parameter lambda negative 1, 3, 1, right? Find the perpendicular distance from a point A to the line L, right? We want to find the perpendicular distance, right? Remember, distance can be also called length, right? Distance can be also called modulus. Distance can be also called magnitude, right? So it's one and the same thing. Modulus, length, magnitude is one and the same thing, right? So we want to find the distance from a point A to the line, right? First of all, we have to make a sketch. Right. Let's just make a sketch of what we are going to produce. Right. Remember, we have point A, right? Point A given, and also the equation of a line R, right? So remember, we have this line. Assuming you have this line, which is point A with the coordinates. Coordinates 3 minus 6, 1, right? Point A with coordinates, these ones. Then also are given a line, like this line, right? Just a line. A line R is equals to 7, 1 minus 5 plus lambda minus 1, 3, 1, right? But we are asked to find perpendicular distance. So we want to find a distance from this point A until from point A until we reach this line. R is equals to 7, 1 minus 5 plus lambda minus 1, 3, 1, right? So we want to find the distance. We want to find this distance from A up to here, right? We want to find this distance. So for us to find this distance, first of all, what you have to do, let's convert R is equals to 7, 1 minus 5 plus lambda multiplied by direction vector minus 1, 3, 1. And form what you call a parametric equation, right? So it becomes R is equals to, let's just form a parametric, 7, then minus lambda, just say 7 minus lambda, then 1 plus 3 lambda, 1 plus 3 lambda, then minus 5 plus lambda. This is the parametric of the given line, right? So since we have this parametric of the given line, remember, we want to find the distance from this point to this point, right? Let's just form this distance in parametric form, like what you did here. So what you have to do is we have to say point A minus point A subtracting this parametric equation of this given line. So we are saying R, which is a line, subtracting let's just say point A, which is OA, is subtracting this given line, which is R, right? So what you have to do is you're given 3 minus 6, 1. Let's just say plus 0 lambda, plus 0 lambda. It's just the one and the same thing. This thing is simple as this one, because 0 lambda is no effect. 0 lambda is no effect on the equation. So subtracting 7 minus lambda, 1 plus 3 lambda minus 5 plus lambda, right? 3 minus 4, which is 7, which is negative 4. 3 minus 7, 3 minus 7 is negative 4. Then 0 minus lambda to give us plus lambda. 0 minus lambda to give us lambda. And negative 6, negative 1 is negative 7. Then 0 minus 3 lambda. 0 minus plus 3 lambda to give us negative 3 lambda. Then 1 minus 5 to give us 6. 0 minus lambda plus minus lambda. This is the distance from point A until we hit this line, but in parametric form. So what you have to do is, since this one is in parametric form, what you have to do is Since this a point in the line, they are perpendicular to each other. They are perpendicular to each other. Remember, given point is parametric. Given point is perpendicular is perpendicular to this given line. Remember, when two lines are perpendicular, or even a point in the line, they are perpendicular to each other, meaning that their point of intersection, they form 90 degrees. They form a right angle, right? So we are applying the concept. So what we are saying is now we have this one. So this one multiplied by. So as we know about perpendicular vectors, we know when vectors they are perpendicular to each other, their dot product should be equal to 0. When vectors are perpendicular to each other, meaning that this point is perpendicular to this line. When vectors are perpendicular to each other, their dot product or their result after dot product should be equal to 0. So meaning that this parametric from subtracting this point, subtracting the parameter of the given line multiplied by, we are multiplying by the direction vector of the given line. Since they are perpendicular, multiplied by the direction vector of the given line is 3, 1. They should give us 0. So we are doing what we are doing. What the reason why we are doing this? We are doing this in order to find the value of a lambda. We want to find the value of the parameter lambda, so that if we get lambda, then we are now able to find this point R, right? So let's multiply. -1 is subtracting -4, which is 4, to give us 4. Then this one times everything, right, to give us -4 lambda. 4 minus lambda. Then 3 subtracting this one to give us -21 minus 9 lambda. Then 1 subtracting this one is no effect. So plus 6 minus lambda should be give us 0. Since they are perpendicular, the product should be equal to 0. So meaning that, so for let's just use calculator to make a calculation simple. So we are saying 4 minus 21, 4 subtracting 21 is 4 subtracting 21. We are grouping the like terms. 4 subtracting 21, then plus 6 to give us -11. To give us -11 for constant values. So negative lambda, -9 lambda to give us -10 lambda. -10 to to give us -11 lambda. -11 lambda, they should give us 0, right? Grouping the like terms, we are now solving the linear equation. We want to solve the linear equation in order to find the value of lambda. So meaning that minus lambda is equals to 11. We want to find the value of lambda, divide both sides by -11. Therefore, lambda is equals to -1. Now we have the value of lambda. So what have to do when we have the value of lambda now? Now we have this value of lambda. So lambda is equals to -1. So back then we have the value of lambda. Let's visit our line in parametric form, which is this line in parametric form. We are now visiting this line in parametric form and substitute this value of lambda by -1. It becomes, let's just use this space, r is equals to, substituting, it becomes 7 minus -1. Remember, lambda is -1. So negative is from the formula given. Then the other one is 4 lambda. Then we have 1 plus 3 lambda. But remember, lambda is -1. So -1 times 3 give us -3. Then minus 5 plus lambda. But remember, lambda is -1. So -1, -5, -1 to give us -6. So -5, -1. All right. So this point becomes 7 minus -1 to give us 8. Then give us -2 to give us -6. So now we have our point. Using this point, I can write here, using this point, r is equals to it becomes 8, -2, -6, right? Using this point and also this point, we have 2 points. And the point A from the question, which is 3, -6, 3, -6, 1. Using this point, after finding the value of a parametric lambda and also this given point, we are now able to find, meaning that their point of intersection of this point and this line, they intersect at the point 8 -2, 6, which is this point. So this point, it becomes 8 -2 -6, right? Their point of intersection. So I want to find the distance from point A up to this point of intersection. Which formula are we going to use in order to find the length? Remember, we want to find the perpendicular distance. Perpendicular distance it's like we want to find the length. We can also say we want to find the modulus. We can also say we want to find the magnitude, right? Right, so what you have to do is applying the formula. We all know the formula of calculating the length. So we have to say the length is equals to the square root of x2 minus x1 all squared plus y2 plus y2 minus y1 all squared plus z2 minus z1 all squared under modulus, right? You can name your points. I can name this one becomes x2, y2. I can just say this one becomes x2, y2, z2. This one becomes x1, y1, and z1, right? So using the formula, it becomes 8 minus 3 all squared plus minus 2 minus 6, it becomes minus 2 plus 6 to give us 4. So minus 2 plus 6 all squared plus z2, which is minus 6 minus 1. So minus 6 minus 1 all squared. This is equals to 8 minus 3 to give us 5 squared plus minus 2 plus 6 to give us 4 squared plus minus 6 minus 1 to give us minus 7 is to give us minus 7 squared. It becomes the square root of 25 plus 16 plus 49. So now we have 25 plus 16 plus 49. I can rub here. It becomes our length becomes the root of 25 plus 16 plus 49. This is equals to, you can use my calculator to make our simple. So just say 25 plus 16 plus 49 to give us 90. This gives us 90, right? Gives us 90, but we don't leave our answer in this form, right? Remember, we can express 90 in said form. So it becomes the root of, what's 90? It becomes 10 times 9, which is equals to the root of 10 times the root of 9. It becomes root of 9, which is 3. 3 times root 10, which is 3 root 10. Meaning that 3 root 10 is the length. I can say just say 3 root 10 units. Remember, we're calculating a length, perpendicular distance from point A to a given line. So this is the procedure you have to follow whenever you're asked to find the angle from point A to the given line, the perpendicular distance from a point A to the given line. Please guys, after watching, please don't forget to subscribe so that you enjoy more videos. We are still uploading videos week by week. You will receive a notification of a new video. So just subscribe and turn on your notification button so that you enjoy more videos until you are done with your exams. Please don't forget to subscribe so that you enjoy more videos on this channel. So for those who want to join our online classes, we are now open for 2025 enrollment starting 1 November, right? Starting 1 November, we are now enrolling for November 2025, even June or November 2025 candidates. We are now enrolling for those who want to attend our online classes. Please contact us on the number below so that we can start with you earlier so that we can enjoy our online lessons. And also those who are located around Kwazano areas around, you can contact us and get in touch so that we can assist you face to face. So thank you guys. Just subscribe and also share these videos and also YouTube links with your colleagues. Thank you so much.